Here we go. Time to step it up a notch in this part of this section. Now, we just talked about simplifying rational expressions. We just talked about adding and subtracting. Now it's time to kind of put that all together by doing what we call simplifying complex fractions. Oh, yeah. This is good stuff. I love this. This is like the culminating of everything we've done. So here's your definition. Complex fractions is a fraction that contains a fraction in the numerator or denominator. Now, by the way, this word or doesn't mean one or the other. It could be in both. It could be in the numerator, or it could just be in the denominator. 3 examples that's in here in red. Here's a complex fraction. The big old bar right there is a fraction bar. Fraction bar. Fraction bar. Yes, you're right. That's a fraction bar too. Yep, is that. But you see, complex fraction by definition, there's a fraction in the numerator and actually 2 fractions in the denominator. Here's a fraction in the numerator. It's a very simple one, just numerical. Just regular old fractions, but by definition, it's a complex fraction. Fraction in the numerator, fractions in the denominator. Fractions in the numerator, oh yeah, and fractions, plural, in the denominator. So that's the deal. We're going to talk about taking these things right there and simplifying them down as much as we possibly can and tying everything together. Now, here's your 3 steps you need to write down. We're going to use these as we go through the examples. To simplify complex fractions, first, you're going to write the numerator as a single fraction. So you want it to look something like that. That's a single fraction. Or something like that. That's a single fraction. That's not a single fraction. Those are 2 fractions. Those are 2 fractions. Those are 2 fractions. So first step, get it looking something like that. Second step, write the denominator as a single fraction. So the first thing we do, get this bad boy single, and then down here, get this one single somehow. We'll talk about that, and we've already done it anyways. But anyways, last step, after you get a single fraction at the top and a single fraction at the bottom, you're going to keep it, change it, and flip it. That should sound familiar. Which just basically, like we talked about before, you're dividing by multiplying by the reciprocal. Weird. When you divide fractions, it's the same as multiplying by the reciprocal. So, let's rock and roll. Let's do these steps. So, step number 1 in doing this example. And this example is a complex fraction. It is the example I just showed you over there. 3 over x plus 1 divided by 1 over x plus 1 plus 3/4. What is up with that, boy? Here we go. So step number 1. Let's write the numerator as a single fraction. Check. Got it. Peace. So we'll write that up here. 3 over x plus 1. Got that taken care of. Nice. Step number 2. Write the denominator as a single fraction. Well, you see the denominator right here, not a single fraction. So what do we do? Well, it's as if you do this. Treat this complex fraction as 2 separate parts. The top part, numerator, and the bottom part, denominator. So we need to take, if this wasn't up there, this is a simple addition of rational expressions like we just did a couple examples in many days in class, many examples in class over the past couple of days of adding those. You do the same thing. Let's look back at our steps and see how we do that. Remember, you look at these 2 things, factor them as much as you possibly can. Well, there's nothing to factor right there. Sweet. So you need to come up and construct your LCD, the least common denominator. Well, if these are my 2 denominators, I have a 4 and 1, which means I need a 4 in my least common denominator, and I have an x plus 1 in this one. If I look at these 2 denominators and I want to construct one denominator that covered both of those denominators, here's what I need. I need a 4 times x plus 1. That is my common denominator. So, I use that common denominator and then look at these individual denominators and say what's missing. Well, if 4 is in this denominator, it's missing from my least common denominator and x plus 1. So I multiply the top and the bottom by x plus 1. Sweet. Over here, I have x plus 1 in the denominator. What am I missing? I'm missing the 4. So I need to multiply the top and the bottom by 4. So when I do that, multiply 4 times 1 gives me 4. That's why that's here. 4 times x is 4x times whatever, there it is. It's that guy right there. I wouldn't distribute it through there. I just keep it like that because, again, I'm looking for a common denominator. So just keep it as factored form like that. So over here, I distribute the 3 through the x. and the 1. Sweet. So that gives me 3x plus 3. And then, of course, the denominator is 4 times x plus 1. So there's my common denominators. I got them right there, right there. So that means I can add the numerators together, keep the denominators the same. Bam. 4 plus 3 is a 7. 3x just stays 3x. So there's my denominator. All that work, remember, to take this denominator, do all this work to it like we just did in the last section, the last couple days, and write it as a single fraction. So that bad boy goes right here. 3x plus 7 over 4x plus 1. So there is step number 2. We've got the denominator written as a single fraction. Step number 3. Keep it, change it, flip it. That means this. You keep the top one, or the first one like we talked about. We keep that one exactly the same, so it's 3 over x plus 1. We change the fraction bar, meaning the division to multiplication. Yup, yup. And then we flip this one, whoop, like that. So it goes 4, sound effects are important, whoop, x plus 1. And then this goes down here, 3x plus 7. So we just, again, keep it, change the fraction to multiplication, and flip this one. Exactly it. And then, boy, I should have put this step up there, although you should know it. Now what we must do is the steps like we did before when we multiplied and divide. We just go through and clean it up. That's multiply across the top, which would give me 12 x plus 1. And then in the denominator, I would get, ooh, what is going on? That's really ugly. Well, I just do this. X plus 1, 3x plus 7. I would just do that. That's not multiplied out. Here's why. Do you see it? Well, if you really look closely, I see some things that I can cross off. I see some factors that are exactly the same. I see an x plus 1 and an x plus 1. Oh, yeah. So, I have 12 in the numerator. I'll write it down here. I have 12 in the numerator. And what I have left in the denominator is just 3x plus 7. Now, if I could factor something out of this like a GCF, phenomenal. If it was a difference of 2 squares, phenomenal. Factor it. Problem is, there's nothing that I can do with this. I can't take the 3 and cross off the 12. Can't do it because that's grouped together. So you cannot do it. They're not factors. So I would just probably erase these bad boys. And I got that right there. And this, ladies and gentlemen, is your final answer. Wonderful. Welcome to simplifying your first complex fraction. You're awesome. Let's do another example. Now you watch this one, kids. This one will blow your socks off. This one's pretty cool. Simplify this complex fraction. By the way, here's the original example. This guy right here. Holy moly, moly, moly. Look at that thing. You got 2 fractions on the top. You got 2 fractions on the bottom. So, needless to say, you have your work cut out for you. Let's do it together. Here we go. So,